Welcome to my YouTube channel. We are still watching ETA. Now, this is the place whereby we bring you the best in maths, physics, and chemistry. So today, without much waste of time, let's get right into it. Now, today I'm going to be teaching you guys algebra, whereby we're going to be solving equations. Now, the first equation is what you're going to see on the screen. Now, for those who don't know, we're going to be starting with the March test papers. I'm going to start with last year's paper for Gauteng. Without much waste of time, the first equation reads x into 2x minus 3 equals 0. X into 2x minus 3 equals 0. Now, this is very easy because we deal with vectors. This will be x minus 0 into 2x minus 3. What we know is that if we take all the vectors and equate them to 0, we can find the roots or the solutions. The second vector is 2x minus 3. We equate it to 0. This is how we find solutions. So x equals 0, or 2x equals, if you take minus 3 to the other side, it becomes positive 3. To get x, you have to divide by 2 both sides. 2 cancels 2. So we are left with, let me rub off. So we are left with two with x equals 3 over 2. So we have two solutions in this question. The next question, let me write it down properly. Two x squared minus 5x. 2x squared minus 5x minus 11. Let me see if I wrote it properly. I made a mistake. 3x squared. Now, to get the solutions of this equation, there's different ways to do it. But the quickest way to find the roots of an equation is to use the quadratic equation. So I would advise you as a grade 12 learner to not even bother try to work out factors using your head. You just have to use the quadratic equation. Then you will be able to solve these quadratic equations in properly. So the roots of any quadratic equation is given by minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, to determine the value of a, b, and c, our a in this equation is 3. Our b, this is our a, this is our b, and this is our c. All right. Now, we're going to get minus 3 plus or minus the square root of minus 5 squared minus 4 times a is 3. Now you see is minus 11. You must always watch out for the signs because they can get messy and confusing. 2 into a. Now your a value is 3. So going down, we will have minus 3 plus or minus the square root of minus 5 squared will be 25. 25 minus 4 times 3. 4 times 3 is 12. Let me see. Yes, 4 times 3 is 12. And 12 times 11 will give us, let me see. Four times 3 times 11. It will give us, and be careful of the sign, guys. So negative times negative will give us a plus. So it's going to be plus 132 divided by 2 times 3, which is 6. Now this is equals to minus 3 plus or minus the square root of 25 plus 132. It will be the square root of 157. Divided by 6. Now, minus 3 plus the square root of 157. Now, the square root of 157 will be, let's see, it will be 12.53. So this will be minus 3 plus or minus 12.53 divided by 6. Now the first root will be, now x will be the first root. We will have, let me calculate it for you guys. So it's gonna be minus 3 minus 3 plus 12.53 divided by 6. It will give us 1.5. 0.59. That's the first solution. Or, because we have plus or minus. So if we say minus, we are going to get minus 2.59, or x equals minus 2.59. Now, these are the two solutions that we have. I will always advise you guys to use the quadratic equation, regardless of whether the solution is a fraction or not. So we are done with number 2. Now, number 3 says, okay, so we have x into 3x plus 4. X into 3x plus 4 minus 2 into 3x plus 4 minus 2 into 3x plus 4 is less than or equal to 0. Now, this is very interesting because now we are not dealing with equalities. So if we're not dealing with equalities, we are dealing with inequalities. So with inequalities, it's when we talk about greater than or equals to, or greater than or less than or equals to. Now, when we talk about inequalities, we're going to talk about regions of the quadratic equations, or the regions of the parabola, if we're dealing with the parabola. Okay, now how do we solve this equation? First, we're going to treat this equation as though it is an as though this sign is an equal sign. So we have common factors, which are 3x plus 4, which are appearing on both sides of this minus. So this is a factor. Then if we take it out, we're going to be left with x minus 2. If you can't see what I did, you can go to the comment section and put your comments. If you can't see what I did, please go to the comment section below. I will explain it to you. Okay. Now, this is what we have. Now, as you can see, this is a quadratic equation. Now, a quadratic equation is linked with a parabolic graph. Okay. Now, already you can see the two factors. The other factor is we have 3x plus 4 equals 0. I'm going to repeat the same thing I did on the first solutions that I did on 1.1, on question 1.1. So we're going to have x minus 2 equals 0, and also 3x plus 4 equals 0. Now, to solve this one, it's a bit easier. You take 4 to the other side, then it becomes minus 4. Or the same thing we did here, we're going to do it here. If we take minus 2 to the other side, it becomes plus 2. Okay, so x is equals to, if we divide by 3, we're going to get x equals minus 4 over 3, or x equals 2. Now, these are the two solutions. Now, let's go and draw the parabolic graph. Now, let's see. Let's go back to the equation. what you can notice about this graph is that it has a positive A value. Now, for those who don't know what I'm talking about, let me go to the first question, to the second question, 1.2. This is the A value. In a quadratic formula or in a parabolic equation, we have A, B, and C. Now, to check how your graph will look like, you can check the value of A. Now, if the value of A is positive, it means your graph will be happy. So if your graph is happy, let me draw the Cartesian planes. If you do not understand what I'm talking about, please do not hesitate, go to the comment section. I will explain it to you. Now, this is a happy graph. And by the way, our happy graph will have x-intercepts. Why? Because it has solutions, or it has x values that are real. So this is a happy graph because your A value is positive. To see how your A value will be, if you multiply these two extreme x values, 3x multiplied by x, you will get a positive 3. So it's a happy parabola. It's happy. All right. Now, this will be minus 4 over 3. And this will be 2. These are the two solutions. Now, let us go to the equation itself and see how we have to draw the graph. So if you check this inequality, your inequality is saying, let us check the region whereby, okay, whereby your graph is on the negative side of the y value. How do we check that? If you want to check where, if you are checking this sign here, this is the smaller portion of your inequality sign, and this is where your graph is. Your graph is here, and it's on the smallest side of your inequality sign. It means it will be on the smaller or the negative side of your y value. So this is your y value. So that equation is saying go in the shade where your graph is less than 0. This is where your graph is less than 0. Now, this is the region we are talking about. This is the region. This is it. All right. If you draw this in the exam, you are getting all the marks. If you don't get all the marks, you can go and comment in the comment section and tell me straight if you didn't get them. Then I will see what I'm gonna do for you. All right. Now the last question, 1.2. Okay. It may look difficult, but it is not. We are actually going to apply fundamentals. So what we have is the following. we have, let me see it properly. Let me see it properly. Let me see it properly. So we have 4 plus or minus the square root of 8 minus P3. We have x equals 4 plus or minus the square root of 8 minus P3. It's all divided by, let's see, all divided by P. Guys, don't panic. This is very easy. We're going to use fundamental principles to solve this one. Now, the most critical portion of your quadratic equation is everything that is under the umbrella, or rather, everything that is under the square root. That is the most critical part of your quadratic equation. So that's what we're going to consider basically. So I don't know if you're going to agree with me. Let us go to the equation, to the question itself. They are saying the roots of the quadratic equation in terms of P are given in the following. Determine the value of P for the roots to be real. Now the question is, in order for the roots to be real, how should the value under the square root be? And the answer is that the value under the square root must be, sorry, P3, 8 minus P3. It must be greater than or equals to 0. If not, it's not going to be real. Therefore, 8 is greater than or equals to, let's take P3 to the other side. So we're going to have P3. All right. Now, I'm sure you can see where we're going. Okay. I don't know if you're going to agree with me, but 2 to the power of 3 is the same as 8. Now, what do you see from that? You can see that the exponents are the same. Therefore, the basis must be the same as well. So therefore, P is equals to 2. Not equal, sorry. P is greater than, is less than or equals to 2. It must be less than or equals to 2. Otherwise, if it's greater than, then the values won't be real. Let's say, for instance, if we take a value which is less than 2, let's say, for instance, 1. If you put 1 there, you're going to have 8 minus 1. 8 minus 1 is 7. Now, the square root of 7 is real, which means our solution is valid. Our solution is valid. And that's it for today. Thank you so much for watching this interesting and very informative YouTube video. Now, if you want more, please click like and subscribe for more content. Thanks.